right, ladies and gentlemen, welcome to another episode of the Creating Structure podcast. I'm your host, John Wheaton. Today we're having the energy discussion in the facades that inspire subcategory. So welcome. Get ready for a engaged discussion here. I have Mark Schow, PE, Elevated Design, David Kent, Lead AP, Wheaton Sprague Building Envelope. Gentlemen, welcome to the show.
Great. Thanks for having us.
Mark, tell us who you are and where you work. Tell us a little bit about yourself and about Elevated Design, Inc.
Yeah, thanks, John. My name's Mark Schow, and I started this firm as a side gig 5 years ago as Encore Boston Harbor was winding down. With another firm, I was the lead mechanical engineer and lead project manager for all the MEP, that went into that building. We had in-house architecture, so I worked closely with the architects on all aspects of that building. Really got intimately familiar, and it was a great launching ground to start my own firm. So I've been full time since the day they opened, which is 4 years ago, just over 4 years ago. And we've grown, and we're at 5 engineers now, and we have a lot of fun designing high efficiency buildings.
High efficiency, thanks for that. We have a similar path. I started Wheaton Sprague as a side gig too, and the side gig eventually moved to a full gig. And high efficiency buildings, you're focused on the mechanical systems, correct?
Yeah, mechanical, plumbing, and then we do fire protection because you got to keep the buildings up.
Beautiful. David, tell us, I know you've been on the podcast once, but for those that haven't heard, tell us who you are and what you do and a little bit about yourself.
Yeah, so my name is David Kent. I am a senior building envelope consultant at Wheaton Sprague. My background is in building surveying, which is a degree all about the aftercare of existing buildings from the UK. I've spent 20 years looking at all envelope aspects, maintaining and restoring and improving buildings' energy efficiency through the envelope in London and in New York, and now on a more broader basis with Wheaton Sprague nationwide.
Beautiful. Thank you very much. Everybody knows me as the host of the podcast. I guess I'm a podcast host who happens to do professional engineering work. I don't know. I'm a lot of different things, but for right now, I'm a podcast host, and it's awesome to talk to you both. So today we're going to talk about energy efficiency, energy savings, energy mandates, the relevance of the interplay between mechanical systems and the building enclosure. And just for sake of further introduction, the three of us were speaking a while back, a month ago or so, and we were talking about the Massachusetts stretch code as opposed to the base energy code. And we were talking about BERDO from Boston. And then Dave and I have been talking about Local Law 97 with some strategic partners and such in New York, which is also an energy mandate. But I like how you guys said it in advance. Maybe you could weigh in a little further. Like, this isn't just about those mandates. This isn't just about Massachusetts or New York, although that's relevant, right? This is about energy savings overall. You want to weigh in on that a little bit?
Yeah, I can jump in first. So exactly what we had said before we started the podcast is that, BERDO is specific to Boston, and Cambridge now has their ordinance, and Massachusetts has an opt-in stretch energy code. There's all these important vocab words that people local to this region need to know about, but New York has their codes, and the rest of the country is falling right behind in all of these. And the basic applicability is that wherever you are, energy is getting more expensive, and legislation is causing it to become even more expensive with whether it's, carrot or stick, however they're incentivizing it. There is just massive incentive, and it is only snowballing to become more. So for people to have at least a conversational knowledge of how to make their buildings more efficient and how to move down this road that needs to be moved down is a huge advantage. So, I think this could be a great podcast for people that are experienced in the industry as a refresher, and for people that are, maybe they own a building or they work on buildings, and, they're not necessarily experts on the facade and mechanical systems. I think it's a great podcast.
Thanks, Mark. That's well said. I think, David, anything to add to that?
Yeah, I think that's really well said. It's the code is making everybody nationwide, consider how they're going to build new buildings to meet them, and also how to maintain and make their existing buildings meet it, no matter where you are in the country. So I think it's valuable. This conversation is valuable for everybody, everywhere, regardless of what codes we talk about throughout. So.
Yeah, thanks for that. And even though I know that the carbon emission thing is a political issue as well, but regardless of where one stands on that, to me, energy efficiency, operating a building in an optimal manner for the least amount of energy is just a good thing. It's a smart thing. It whether it's a renewable or a depleting resource that we're using, it's just good for people. It's good for society. It's good for building owners. And ultimately, I think all of us are, if you really move upstream, we're all in the commercial property protection or the property protection business, right? Because we're trying to bring efficiency in design and cost and interplay and balance to really a significant amount of assets. I mean, there's more commercial building assets in the United States than any other single asset. It trumps it. I shouldn't use that word. It greatly, it is much greater than any individual tech company balance sheet or combined balance sheet. There's trillions of dollars of commercial building stock and industrial building stock in the United States, trillions, tens of trillions of dollars, and it all has to be properly conditioned and properly protected. So I know that the number I read was that buildings in Boston account for 70% of greenhouse gas emissions. That's pretty typical number. I think it's 55 to 65% ish nationwide. And so the more we can save money in that manner, the better. More we can save greenhouse gas emissions, I should say. So let's jump into it further. I liked your setup. Mark, I like what you say I put you on the spot here, your tagline, using less energy by design. Could you just kind of give us your mindset behind how does Elevated Design, before we talk about the interplay with the cladding, how do you and your firm go about designing to use less energy by design?
Yeah, it's always been a personal focus. And so when I started the firm, it was definitely going to be a building, an industry, a company focus. So I actually started in the power industry. We were, working on power plants, and nuclear power plant was, as carbon free as you can really get. But for economic reasons, they don't make a lot of sense. And I was lucky enough to make a move into the buildings industry a few years into my career. And so that's just been the focus. That's what I've wanted to do, is decarbonize as much as possible since I was in college. And so that's what we continue to do. So here we are many years later, and, it's every project, even in projects that don't feel like they're going to be using less energy, client comes with a code minimum building or whatever, existing clients. We're still pushing them, saying, hey, you really don't want to be code minimum here. And code minimum's getting pretty good now with all these opt-in codes and everything. Code minimum's pretty good. But we really push on our clients to always be thinking a little bit harder about whether they can, stretch to be a little bit further along where they should be.
Thanks. That's really clear. That's really good. Yeah, I do remind people occasionally, and it always appears to be a well-received comment. Building code is the minimum acceptable standard for building structures, not the maximum. Depends on who you're hanging out with as to whether they think it's the max or a min. But I often remind contractors and subcontractors, this is the minimum. We could design it for more, but we're just shooting for the minimum here. So that's a good point. David and Mark. David, let me ask you first. Speak to, where does the building envelope, building enclosure come in related to the energy equation? And then we'll talk about the interplay between the building enclosure and the mechanical system and how we help optimize for design with each other.
So in new build, you look at the construction, because of the amount of energy that the envelope loses and uses the amount of energy to heat it. That's usually a really big aspect of new build. So that's where they really focus on the envelope so as then they can size the right mechanicals and can get the most efficient construction new build out there. Because you can do all the air barriers, you can put all the air barriers in, do all the testings, you can see it all, right? So that's a really big area where you can meet your energy requirements for the building in a new build. When you go into an existing build and you're looking for improvements, you kind of flip that upside down. Yes, your envelope is one of your largest areas where you can save energy, but it's also one of the most expensive places where you can put money in to get the results that you're looking for. So when you're going into existing build, they often look to the mechanicals and the easy fixes first that they can sort of swap out, and then you want to sort of factor in. So in the long term, you then want to factor in your long-term maintenance planning, and you want to factor in what you can do on your envelope to get the really big gains, which are going to help you meet these energy code requirements. Local Law 97 is the one I'm more familiar with. It steps out exactly what you got to meet at what stage. So then you can sort of plan and say, so I can meet X amount with the mechanicals, but then I also have to do my facade maintenance. So then I can also improve my facade, and that can sort of help me meet my next goals. Even though it's a bigger cost, you're going to have to do it at some point. So I think there's two very clear paths. I mean, with the new construction path and then with the existing construction path, and both the mechanical and the envelope are, it's the be all and end all of meeting your energy requirements. There's the two things that have to be coordinated together.
Okay, thank you. So either of you, well, let me ask Mark first. As a mechanical, when you're brought on board for a new or an existing, is there usually a building envelope consultant or not?
Yeah, as a new firm, we're still working on smaller size buildings. So typically there is not. Certainly when, we did Encore, there was, and we've been on a few projects with it, but most of them do not. It's left up to the architect, and that's in their domain.
Yeah. David, what about an existing build? Are owners, architects typically just calling in the mechanical and not even dealing with the cladding, or are they calling in the cladding first, or what's your experience?
So what I'm finding is that the building owners are seeing that they have to meet these requirements. So they call up a mechanical engineer and they say, give me a more efficient boiler. So they put that in and they don't coordinate it. And then they end up having potentially an oversized boiler in the future, based on the upgrades that they're going to need to make on the envelope anyway at a later stage. So I think there's a lot of miscommunication. I think right now it's very easy for building owners to go in and say, I got to meet these goals. How do I do it? They call up someone like Mark, who not like Mark, because he does consider the envelope. Other engineers out there who won't consider the envelope, and they say, yeah, I can get you to meet this. We can swap this out. And they put in something which is more efficient, but going to be largely oversized in the future. So I think the biggest change, and one of the things that the codes are driving towards, is trying to make the design team and the owners really consider how to implement the changes over time for the most cost-effective way.
Yeah, thanks for that. I'll admit, as much as I'm a, low bureaucracy, keep the law to a minimum kind of a guy, I was part of a facade tectonics focus group discussion. They brought in 17 or 18 people that have been at this for a while. And one of the questions was, why aren't we further along with facades, with enclosures? Why aren't we further along with their functional capabilities in reducing energy consumption? And I said, as much as I hate to say it, if regulatory requirements drive it, because people want to do the minimum necessary and invest the minimum amount. And I said, if it weren't for the if it weren't for the federal government, we probably still have seatbelts as optional and people flying through windshields in cars. But, it's mandated that you have to have seatbelts in cars. And the same thing I said, I hate to say it, but you've got to have energy compliant. Like, that has to set the pace. New energy standard, new U value standards. And people always go, that's ridiculous. That we can't do that. But it also drives innovation, right? It drives technology. It drives design approach. And the world is better off for it in the end, but it's not an easy place to get to. And I just think I hate to be saying it, but with the nature of humans, without appropriate regulatory requirements, I just don't think we'd ever get there. It would only be those corporations, building owners, and people like Mark who wants to, reduce greenhouse gases, reduce carbon. It would only be people that were principled that said, well, I'm going to invest in that no matter. It'd only be the Patagonias of the world that do that, right? So I think by and large, the regulations are a good thing. Now, how do we work together to get there? Just a quick aside. One of the things that I'm thinking about, though, so I know it's in the Massachusetts stretch code, air leakage testing is now mandatory. And I'm thinking, so if Mark or a guy like Mark is hired and they design an HVAC system and then nobody really commissions the envelope, aren't we kind of fighting a losing battle if we're not measuring air infiltration into the building?
Yeah, I couldn't agree with that more. We've been really seeing, particularly on abnormal buildings, we've been seeing a lot of focus on trying, internally. I don't think we've seen it elsewhere, but we as a company have been trying to focus on really getting that dialed in. We've ordered blower door tests on a few buildings that we're renovating because, we're looking at the cost of mechanical equipment. It used to be, if you wanted your mechanical equipment to be 10, 20, 30% oversized, it didn't add 10, 20, 30% to the cost of the project. And it was certainly not the whole project, not even the mechanical budget went up by that much, right? Because a bigger boiler, you knew that you had, hydronic systems are kind of self-healing. VAV systems are kind of self-healing. If you ended up off by a little bit, you get a little bit better transfer of heat and you get a little bit bigger delta T or whatever it is, and the system just kind of works. Well, now with VRF systems, they get less efficient as the colder temperatures go down. So right as we need the most heat, they produce the least amount of heat. And their cost per unit of energy delivered, the installed cost is dramatically more than what we've been used to as an industry. So as an industry, we can't just be going in and doing the same calcs that we've done forever and saying like, okay, well, you need a boiler or, a heating system of this size. We're really getting to the point where not only do we have to, improve the ventilation or the facades to reduce this infiltration, but we at least have to know what it is so that we're not putting in an oversized system.
Thank you. David, can we install a wall? Can a wall be installed that has a proper U value and proper thermal breaks specified and still have inordinate air leakage that is detrimental to the operations of the mechanical systems and the building performance?
So are you asking if someone can install a new wall that's meant to meet code, but then leaks like crazy? Yeah, if there's bad workmanship, yeah, sure.
Hence, air leakage testing is now mandatory. So, David, what's the value of a blower door test that Mark references?
So the blower door test will tell you the air change per hour. So that will tell you how many times, that will tell you what sort of, that'll tell you the size of the equipment that you need to put in to be able to keep everything at the right temperature. So along with the U value and the air leakage test. But part of the other thing in the planning of it is you want to meet these air change requirements, right? So testing is one of the things to show that you've met the requirement that the unit is being sized to. So part of what we would do to make sure that the design is going to work and get these air changes is that we would look at the wall assembly, we would look at the windows, we would do rated U values, we would look at the thermal bridging, we would look at all these things, because all of these things add together to make the right thing. So we would model the envelope or the improvements of the envelope, and we would estimate on our modeling what the difference is from the original building to the improvements that we've made, so that Mark could then go ahead and actually with a certain amount of accountability be able to make, with the data that we provide, he'd be able to design the appropriate system to go into the building that we are proposing the upgrades of the envelope for. Without that, I'm not really sure how you would accurately get the right mechanical sizings. I think you could probably guess from what the code is prescribing, but with an existing building, with everything that's there, if you get an existing base rate through the air change and then do this modeling, and you can assume you're going to reduce your air change and increase your thermal values by a certain amount, that's all valuable data that someone like Mark can plug in and design his system and have the most efficient, correctly sized system for the building.
Interesting. But if I'm a building owner, where do I start? Say whether I'm new build or existing. And if that's an unfair question, if there's too much of a demarcation between the two, help me out. But so like, if I'm a building owner, do I contact Mark first? Do I contact David first? How do I know where to start? Mark, you got an opinion on that?
I'll let David go first.
Okay. Oh, sorry, David. Go ahead.
Yeah. Well, I think for a new building, it's relatively simple. You have goals. You know what you know what you need to do, and the design team all comes together and you figure it out as a team. I think it's right at the very start. It's all what performance requirements are. When it comes to a retrofit, it really depends on what they're aiming for, on what the end goal is. I think personally, in the early stages of meeting the early stages of the code to meet so as you can avoid the fines, then I know all the building owners are going to be calling the mechanical people, because that's the low hanging fruit. And for the larger scale, and especially any current wall building from 1980 that I was built from 1980s and beforehand, they all need retrofitting. They should be calling people like us first to figure out when they want to change their boiler. They should be calling us first to figure out what their envelope is, so then we can give that information to Mark, so that then he can size the right thing. So it's really a matter of what the age of the building, the system of it is, and what the goals of the client are in the short and long term as to who they call first. I think it's kind of a complicated question.
Great answer. Mark, any further comments on that?
Yeah, I couldn't agree more. We definitely get a lot of calls about people, trying to reduce their carbon emissions, whether BERDO or whatever focus for existing buildings. And it really is that facade is one of our kind of big head scratchers. We have pretty good rules of thumb to say, well, you probably at 1 air change per hour or some other value for it based on the information we know. And, you probably have a net R value across your wall of, you probably have this in the studs or nothing in the studs. And, here's the construction type and here's what we think your building's at. And then we're kind of saying, well, you can improve that. And there's certain buildings that, we just become passively familiar with without being envelope consultants, that we can say, well, this is a beautiful stone facade. You're probably not going to be putting an overcladding on this, right? And so, but we can only take it to a very cursory level. And so having a team like yourselves on standby that we can recommend to clients where they can then get that professional information and make more informed decisions, that's really important. Unfortunately, some of it becomes they're still bound by the low-hanging fruit concerns, right? So they're saying, okay, well, that's great. We should improve the facade and then do the boiler, but our boiler's about to break and it's a lot less money. So let's, go down this other path, and say, well, maybe that's not the best approach. So it's definitely a complicated position we find ourselves in.
Yeah, thanks.
Yeah, and to your point, Mark, it's like this is exactly what the code is trying to force the building owners to do. It's like, it's not to think about, I have to change my boiler now because it's broken. It's like, I have to change my boiler because I gotta meet requirements So what do I need and what else do I need to do? So then ultimately I can meet my requirements in the long term. And that's, that's a really tough sell to building owners.
Yeah. And there's many variables and factors in that equation. We'll have to get and I will in the near future, we'll get the inputs from a commercial building owner just on, all the different places they can spend their money and have to spend their money in maintenance and upgrades and et cetera. There's a lot more than just cladding and mechanical, but those two things in terms of reduction of greenhouse gases and energy improvement, yeah, it lies there, right? So I have a question about commissioning. So we're talking about improving energy, reducing emissions. Mark and David. Well, first, Mark, are you being asked to do, is commissioning a standard pretty much in your practice? Are owners willing to pay you for a scope of work or are you requiring that, well, if I'm going to do the design, we got to make sure everything's balanced and commissioned correctly, like all the way through operations and maintenance, or not, or does it just vary depending on the owner? And how important is that?
Yeah, it varies depending on the owner. We have some where it doesn't happen and some where it does. Again, we're still on the smaller side, so I'd probably lean towards more of our projects aren't doing proper commissioning. We do a lot of mechanical contractor direct work, and the ones we work with are really top-notch contractors. So I think they, in our experience, have really taken the time to make sure their systems are working and operating properly. But you still run the risk of a disconnect between the owner's sort of operations team and the installer, right? Where you don't end up with the right control sequence and things like that. So it might have even been commissioned properly, but if the occupancy schedules aren't right, people are just, well, why isn't this working or whatever? So definitely important. And unfortunately, it's one of those ones when it's built right, you don't pick up a lot from commissioning, and you kind of one off all the big things that you do pick up. Oh, that one was completely wrong. Well, I'm sure someone would have noticed. And then you walk into some projects years later and you go like, how long has this been operating this way? Like no one ever noticed that this makes no sense and your utility bills are through the roof. But maybe it was only one set of equipment within a larger building framework. So people didn't realize, it wasn't enough to like throw the utility bills way off. So definitely should, it's an important part of the process that more owners should pay more attention to.
Yeah, thanks. How much pressure? So we're design professionals. How typical is it that an owner or an owner's representative calls up Trane, or they call up, they call up a supplier, an electrical supplier or a mechanical supplier first, and they say, hey, I got to meet some energy mandates. Can you help me out? Is that typical, more common than not, or you find people are to call the design professional first?
I would say not supply houses, but mechanical contractors get a lot of calls, right? Because that's the person who's maintaining their building. So the guy who is fixing the air handler when it goes down, just replacing broken belts and doing preventative maintenance, that's who they then are talking to on a regular basis. So that's where we see most people, putting their communication. That's why we then get pulled into a lot of these projects, because it's the mechanical contractor coming to us saying, hey, we have this owner that's looking to upgrade. What can we do to help them?
Yeah, it's you. David, any comments about commissioning on building envelope and its impact on energy?
Yeah, I think it's on new build. It should be mandatory everywhere. It seems to be going more common. There's a lot of times where there's a certain amount of commissioning which is built into the specifications, which is put onto the contractor. So they have I call that kind of a commissioning light. Doesn't really cover everything, but it covers some of the big items. It's difficult to impress on the owners the importance and what it would bring to their building to have a comprehensive commissioning program sometimes on some of these bigger commercial projects. I
think it's interesting, to some of the previous discussion, if one has a baseline, and Mark, I don't know how common this is, but if one has a baseline where they would expect, based on a certain cost of natural gas or a certain cost of power, that their building would cost X to operate, and then it gets, designed and engineered and installed, and now it costs 2X. I don't know if that's as easy to measure as the commissioning. Like, so when you install a wall and now it leaks, it's easy to see the water. The baseline is it's not supposed to leak, but now it does leak, and it can be structurally under-designed and maybe never see a 50 or 100-year return wind load, but now you got water on your sill trim or water on your ceiling. And so I guess my point to that is it's pretty easy to see the negative effects of not having appropriate commissioning when it comes to water or air infiltration. But like when you're talking energy, are you giving customers a baseline so they would know what could I anticipate my costs to be, and they're measuring against that? Or is that like, no, that doesn't work?
It probably could work. I have to admit, we don't do that. So it's definitely not something we're going with. BERDO, the Boston Energy, was actually originally just a disclosure, right? So it was people putting out the information. There was no stake to it. It was just reporting. And so the advantage there was you could then go see where your building compared to other buildings in the database. And you knew if you were ranked at the absolute bottom and like, okay, we have an existing building that's terrible. Like, this is really bad. This should be easy to fix. With new construction, we do the energy models, and they come up with a yearly number. And you're right, it probably would be more beneficial to have that relayed over to the clients and have them checking it. But I think there is often that gap between operations and construction, and that we don't necessarily know who it is that we're supposed to be turning it over to at the time. So that has not been something we've done on a regular basis.
Yeah, and I know energy, is a commodity business, and you're paying different costs depending on geopolitical things versus, and access things and all kinds of stuff, supply chain and, state laws. But I guess my point to that is here we're talking about trying to save energy and trying to meet mandates, but without a baseline, it's harder I think it's harder to recognize the cause effect. Like, it's easy to say, well, 70% of buildings account for 70% of greenhouse gases and gas emissions in Boston. Well, what's the total gas emission? And then how can we improve that? Like, to actually measure quantitatively, where it's easy to see the negative effects of not commissioning a wall because it leaks. It's harder to see the negative effects of not meeting a certain operating standard, but seems like owners would be better off to do that. I like that aspect of BERDO that you mentioned, that it allows you to compare against other buildings. So thanks for that. So how can mechanical engineers, and maybe we've hit on this, but let's get a little more specific. We're trying to meet an energy mandate, or an owner has the integrity and the money, let's say, if they recognize and want to keep the energy costs and greenhouse gas emissions related to their building down, as low as they can be. How do mechanical engineers and building envelope consultants work together? Not only how do they work together, and how do they work together to provide the right, contextual value to a project? Because every project's different, right? Every building use group is different. Building categories are different, multifamily versus commercial, industrial versus warehouse. But let's say in a multifamily or a commercial building, what would be the right way to go about working together in a substantive way to really drive good results? Either of you can take that.
Yeah, I think it starts with David's side of it. The building envelope is what's going to feed into the mechanical approach and design. So, David, I'll let you talk about that aspect.
Yeah, I think I touched on it earlier. It's we have to take a look at the existing conditions. We have to take our measurements, and we have to, then see what we can do to improve the envelope. whether we replace the windows, overclad the building, reclad the building, whatever the system is, and then come up with the new data, the new U values and R values, and the air changes that we can expect, so that we can come up with this, so that we can come up with an overall mechanical and envelope upgrade to meet the goals that the building is looking for. It's going to be a combination of in-person testing, modeling, and then designing the system. It would be a very complex and involved way to make sure that you hit your goals and get the right equipment installed.
Okay, thanks. Anything else to say about that, Mark?
Yeah, no, I think you're spot on. I actually do have a question for you, David. Are you seeing more projects where they agree to the better windows and overcladding for payback reasons, or for, like they're seeing a reduction in the mechanical equipment costs where that's starting to be a better factor? Or is it more driven by, we have failing windows, we're having water infiltration, and that's when people are willing to say, okay, fine, I guess I need new windows because my windows are no longer performing their primary objective?
Yeah, it's the latter. To be honest, it's the latter. I haven't really come across someone who's looking to plow money into their facade because for energy reasons. But when you have a major capital improvement that you have to do anyway, I mean, both Boston and New York and other major cities have facade ordinances, and sometimes you coinciding with that, you got windows which are failing, and like I said, the curtain wall system is maybe obsolete. It's reached the end of its life. So it's those situations then that really the owner needs to not just do the bare minimum at that point, because if they just went back and replaced with the same in kind and they didn't consider the code, then they're going to end up not meeting the energy code requirements in the long run, and they're going to end up having to deal with it or pay the additional fines forevermore. So, yeah, I mean, I haven't come across anybody who has specifically said they want to meet their energy goals by improving just by changing out their facades just yet.
Yeah, and we haven't done any detailed economic studies, but I suspect the old adage that, you'll never save enough on the mechanical systems by improving the envelope is coming down. It was like, before it was never, and now it's like, well, it's there, it's a factor. If you're already doing the work, maybe doing a little bit better to get that mechanical system down. I think we have had a couple of small buildings where, you kind of have these like break points where you kind of can be in, we could get you a couple of under 5-ton systems as opposed to being up in commercial grade equipment. And, so you can make an argument there that you kind of at a breaking point where you can save some extra money with some envelope improvements, but it is still a challenge. I think there's, and I suspect a lot of it is cultural more than reality, right? That we've been saying this for 30 years, is that, a window replacement isn't really an energy efficiency measure in terms of a simple payback. But now I bet we are getting, closer and closer, and I suspect the industry will leave behind it. Once we get that break point where it does economically make sense, it'll take even dedicated professionals will take a little while to, understand that and believe that. The first time they see it, they'll think it's a one-off, and then it takes a little while still. So I suspect we're not too far away from, sufficient incentives and cost of energy. I mean, the cost of energy in New England was outrageous last winter. I mean, I think that was more geopolitical in terms of the utilities had to buy all the energy in, I think, October, when no one knew what was going to happen with natural gas prices in Ukraine and all that. So, I'm really interested to see in a couple of months where the prices go for this winter. But certainly, cost of equipment's going up, cost of energy's going up, and, thermal envelope is the one thing that can really mitigate both of those.
That's really well said. Great discussion. David, any follow-ups on that?
No, I agree with that 100%. One of the things which one of the gains that these buildings are going to get because of the way that they measure their carbon output is related to the electrical consumption. And they're part of the electrical consumption that comes into the building is where that electricity comes from. So, for instance, you cited the 70% of the carbon emissions from Boston. That number changes from state to state based on the greenness of the grid. And as the grid gets greener, the buildings are going to actually start meeting, they're going to start meeting some of these goals without having to do anything as well, regardless of the price. So the price is the driver just to bring down the energy consumption of the building because that's an incentive, right? But to actually meet your carbon caps, as the grid gets greener, you can potentially use more electricity and still meet your caps too. So.
Well, that's assuming that you electrified though, right? Because we're the hope for renewable natural gas is fairly low. There will be some certainly being put into the pipelines, but that natural gas by and large is not going to get green at an effective rate. And so you have to get onto an electrified system. And, for people that maybe are not as familiar with the options, so some of them may be thinking, oh, well, I could put an electric boiler, especially if you have an old steam run building or something like that. And unfortunately, that's not really a viable approach because an electric boiler is going to be 2.5, 3 times the cost to operate as a heat pump system. And on top of that, there'll be infrastructure because it's using all that extra electrical energy. You're going to need a bigger electrical service. So there's infrastructure costs associated with that might seem low at first, but turn out to be quite a bit more. It really is important for people to make sure that they're at least moving to a heat pump system so that they can keep those energy costs within reason. We still generally forecast that heat pumps will be about the same cost as natural gas moving forward to deliver the energy to the building. And we know that long-term, legislatively, they will have to find a way to separate those, and natural gas will have to become more. BERDO obviously is, those sort of regulations are the first cut at them saying, hey, that that carbon emissions of natural gas is staying the same, but the carbon emissions of electricity is going down. So, BERDO is in other similar regulations are strongly pushing for that electrification.
Wow. Great discussion, great education. Thank you guys for that. That's really edifying. I hope everybody benefited from that as much as I did. Thanks for that. That's really good. So are you mentioned this a little bit indirectly in your discussion, sometimes you hear complaints, but so are the requirements of the code, of the energy mandates, like that are either here or coming, they required U values, for instance, in the base code, but then some of these stretch code things, are they reachable now with the products and services that we have, with the design tools we have, and with the products available, both in building cladding and in MEP systems? Is it viable to attain these stretch code requirements or better than base code requirements now?
Yes, there are net zero buildings that are being built out there.
And there's even net zero buildings being rehabbed out there, right? So I would definitely say that technology is there. The economic viability of, maybe 10% of buildings we're in, and we're kind of saying like, well, this is a real challenge. I would say it's really that historic structures are a real challenge. You can't just overclad, a historic structure and even windows can be a challenge there. So there may be some historic commission, relaxation, at least on windows and things like that. And then people need to maybe get a little bit more clever about, really properly insulating and removing those window weight pockets and things like that, as opposed to leaving that like section of gap there that a lot of people don't understand what's really happening in that pocket. But yeah, definitely we're seeing most of it. The technology is there. Electrical service is definitely a big impact for a lot of our buildings, having to upgrade that and how to deal with that. And so that's something that, easily we can do, but is it economic? So what we're seeing a lot of buildings choosing to do right now is partial electrification. So if they can do a couple of floors of a mid-rise or high-rise building, or if they can figure out a way to supplement and leave, if you have a hot water system, you can still use a heat pump system, put in that primary hot water, and then leave your natural gas system as a backup. And then that really allows, the real advantage of that is twofold. One is on the economic cost. So if you install half of your wintertime capacity as a heat pump system and half of it as your traditional natural gas system, you're actually going to see like 85% of the energy per year coming from that heat pump system, because we spend most of our hours north of 20 degrees in the New England area and much of the country, right? So those systems can operate effectively, and they can spend all that time when they're at that higher capacity rates delivering what they can. And the other advantage is actually on the electrical grid side, which gets pretty technical and wonky, but basically if everybody gets electrified, we are having to really struggle with how do we deal with that coldest handful of hours per year during the winter. We're still about a decade away from that being an issue in New England, and the rest of the country is a little bit further away from those being an issue. But it is coming. The wintertime peak load is a real issue. So if you have some of these buildings that don't really stress out the grid because they did a partial electrification, there's a lot of advantage there. So obviously for single family homes, that makes no sense to have like this dual fuel house or anything like that. And for new construction, it doesn't make sense because you can just get that envelope perfect. But when we're looking practically at buildings that, hey, we can't justify the envelope, maybe that's the approach is we're saying, hey, put in this 50% electrification, in X number of years, reclad the building or get the triple pane windows. And then, now your final electrification, you get rid of that hot water boiler in 15 years is a much smaller piece that you can, because now once you reclad, it's just that hot water boiler, the traditional natural gas that's turning off.
That's fantastic. Any comments there, David?
Yeah, in the historic adaptation, it becomes really critical to understand how the mechanicals are working along with the envelope and what upgrades you make with the envelope. And it's super critical to understand how the building works, because you're going to have to explain to the regulatory agencies why you can't meet the code, and you're going to have to go and get an exemption for that, which is done now and it's going to continue to happen, because if you improve some of the elements of a historic building, it can have really detrimental effects on the materials that are being used. So I think a hybrid approach and real knowledge of these properties can definitely improve the energy efficiency of these buildings, but you're never going to get a historic 1700 mansion to perform in the same way as a brand new asset house building. So, there's going to be exceptions for it, and you're going to have to consult with development people to make sure that you get it right. So,
yeah, thanks for that. I know you have a lot of expertise in historic structures, and I was thinking when Mark was talking and you were talking earlier, for example, like, with windows, we early on at Wheaton Sprague with Jack Doyle from Curtain Walls and Windows in Glastonbury, Connecticut, we did a lot of detailing and some engineering of window replacements at Yale. Well, what happens at Yale? It has to match exactly the historic feature, but you can get a powder coated painted steel window with insulated glass from, let's say, Criddle in the UK, and there's other companies here. And
I've done years and years of sightline studies on window replacements in historic buildings.
Yes, but the point to that is to answering my own question and kind of listening to some of the comments. You can improve the efficiency of those windows significantly from old float glass 1/8-inch pane windows with literal leaded caming. And you actually, my partner, he's done plenty of leaded caming drawings where you're actually putting the leaded caming look on or in front of the insulated glass, and it looks exactly like the original iron window with the profile. But I mean, you talk about a drastic improvement. Same with these 80s, 70s, and 80s buildings that have 1/4-inch spandrel glass or 1/4-inch vision glass. I mean, that is low-hanging fruit to replace that with 1-inch low E coated glass with or without a warm edge spacer, you're still going to get a tremendous savings for the glazed vision area. So that's really good. Mark, I wanted to understand but when you say electrification, you're talking about electrification versus natural gas. Is that what you're saying?
Exactly. Yep.
Just like heat pump systems. And I think you answered the question, but I still go back to the early days of heat pumps where, I'm a kid and my dad's got a friend and he's in New York and, now they've got this heat pump and it's 15 degrees outside and we're freezing to death because it can't elevate the temperature in the room enough. Was that what you were referring to? Like the technology of heat pumps, has it gotten really good? Are you saying that below 20 degrees, they're still struggling? Can you just give us a little more information on that?
Yeah, so the heat pumps are really good. If they're designed properly, no question, they can go all the way down. There's no like lockout where they stop working or anything like that. We just had one of the coldest days in a very, very long time this past winter in Boston, and even up through Vermont and Maine. Plenty of heat pumps were installed. I'm sure plenty of buildings were not at 72 degrees when it was negative 15 degrees outside. I'm sure there were plenty that were down to 65 degrees and things like that. But by and large, I think these heat pumps have dramatically overperformed what we as engineers expected. I was painfully opening up my LinkedIn account that next couple of days, expecting to see a flood of like, hey, it didn't work. I had frozen pipes and this and that, checking the news and things like that. And really the heat pumps performed phenomenally by and large. So if they're designed properly, yes. The old heat pumps of 20 years ago, which there's still a few of these for sale, but by and large they have been relegated to not being used or maybe more temperate climates, right? Maybe down in DC, they might be buying a different style than what we specify out here. But yeah. Any of the name brand, there are plenty of brands out there. They're providing systems that work, but even those ones do still have an efficiency drop off, even if it's not a capacity drop off. So they go from being 300% efficient when it's 30, 35 degrees outside, and they drop down to maybe 200% efficient. And the reason why the efficiency is so good is because they're using 1 watt of energy to grab 1 or 2 watts of energy from the outside air. Even if it's 0 degrees outside, it's still 460 degrees above absolute zero, so still relatively warm. And so 0 degree day outside, they're able to use 1 watt to reach out, grab another watt of heat from the air and deliver it to that space, 200% efficiency. But that's still a lot lower than the 250, 300% efficiency we see at warmer temperatures. So that's why, you might have a little bit of capacity drop off or just a system-wide capacity. You're having to pump more electricity in to get that total energy. And so that's why particularly in historic buildings or old buildings, using this sort of hybrid approach of, hey, we're going to use this as the backup. And then also don't forget, engineers have design margin or safety factor that we have to deal with, right? So we do all of our calcs, we get them as close as possible, even if we get a blower door test, even if we, engage with your team to get a good understanding of the envelope, we still, round up in a couple of areas or assume this or assume that. And next thing you know, you have a system that's oversized. And with the cost of these systems being so expensive, that's a lot of money to spend on a system that's didn't need to be quite so big. So with a hybrid approach, we can, size it small. We know it's small because we have the gas system as a backup, and then it's going to run just all season long. It's going to run efficiently and, it's going to run effectively. And then this other system can pick up when the temperature drops below 20 or 15 degrees and fill in that gap. So we've done a lot of studies, a lot of installations, and had a lot of success with that approach.
Sounds like a fantastic approach to me. David, any comments there?
I agree wholeheartedly with that. I had a heat pump and it did exactly what he said. I had a hybrid one in Connecticut and it worked great. And it's what they're driving for. They want to replace all these old gas and oil boilers in these buildings in the big cities. They want to put photovoltaics in. They want to put these heat pumps in, and they want to electrify all the heating and cooling as much as possible because of the efficiency of that Mark was just talking about. It's really, if you can implement it, it's really the way you should have to go.
Yeah, thanks. We're going to have, believe it or not, we've almost killed an hour here. We're coming up to our close. You made a lot of great comments here. We've learned about mechanical systems. We've learned about cladding systems. We've learned about the pros and cons of commissioning challenges, which, hey, totally respect. In the end, we're servicing a building owner, right? Somebody that's got a commercial asset, industrial asset, new or existing building that they're trying to figure out where's the best place to invest their money. But in terms of meeting energy code requirements, not just desires, but the mandates, it sounds like we need to help our owner clients along, and that I think we could do more to, I think, and we're trying to do it in this podcast, we can do more to communicate that it's not just one or the other, it's both. Like there's times where you want to call the cladding consultant, building envelope consultant first, times where you want to call the mechanical first, times where you want to, like to David's point, new build, great, architect, mechanical engineer, structural, building envelope, because everybody's together. What's the goals of this building? As we come to a close, my first question is in Massachusetts, has the stretch code requirement that was started, I think July 1st, 2023, is that a daunting impact right now? Are owners and architects scratching their head? Is there a lot that they need to do, or is it simpler to solve than what it appears to be?
I mean, it's only 4 communities that have adopted that so far, right? So it's the opt-in specialized code, and a number of communities have legislatively adopted, but only 4 have actually had it kick in. So January 1st, we'll see the next tranche of communities to this. So it's definitely a soft start. We have not done any projects in those 4 communities yet under the new code. So we have not dug into it at like a really deep dive, but from what we're seeing, it's a fairly moderate cost impact, particularly if you're going to operate the building. Then I think it's not a big deal because you see a lot of cost savings. You know that you're staring down BERDO or other similar legislation. So I think it's pretty effective within Massachusetts. I do have seen a lot of developers concerned about it because they have to, buy the land at risk, build the building at risk, and then flip the building at their great risk. And so when they see the costs go up by a couple of percent, they're more concerned about whether telling an owner that, your operating costs are going to go down by a couple of percent, will that translate into the sale to cover the installation? And, there's definitely developers I'm seeing on LinkedIn saying, oh, this is killing deals and whatnot. And I'm sure it does, right? That's how the economy works. But the whole idea is that hopefully the best deals do continue and they become more efficient and effective. And so there's a lot of competing things that we need to solve as a society and as a country. And this is one that, there's pros and cons to it. But I generally feel like we've, Massachusetts, these legislative are heading in the right direction and the technology exists. And that you can't rely on, like exactly what you said at the beginning, John, you can't rely on altruism for these things, right?
Yeah.
What percentage of people are going to say, you know what? We really don't need to relay this profit margin to our investors. We're gonna save the world, right? It's not going to be a percentage that's going to save the world, that's for sure. Right. So by having the government come in and say, hey, here's the level playing field, everybody's expected to achieve this level. That's something that now at least developers are working on a fair play. It's no longer that this developer's trying to make an efficient building. It has to now go through like great strains to market that. Well, now everybody's going through that. It's more of the government saying, oh, okay, is this dampening the economy a little too much, or can we accommodate this change within our expectations and our culture and things like that? So yeah, I would say from our experience, and obviously I'm a bias as a mechanical engineer, loving to see efficient systems, it seems pretty viable and pretty doable.
I like that. Yeah, the baseline is a good comment. The car analogy, hey, you're not the only one that has air. Everybody's got to have airbags. Everybody's got to have seat belts. Everybody's got to meet a certain crash test criteria. Okay, level playing field. Now it's all about, what other things can we do to attract customer? David, any recommendations to owners, to those working to meet energy requirements, energy mandates? Any recommendations from your point of view related to any of the things we've discussed, cladding, approach, value, cost of value, etc.?
Well, I think what Mark was saying about meeting the stretch energy code mechanically, the technology's there. It's all ready to go. Talking to architects and owners about it, that concern is having to change the aesthetic of the envelope to be able to make the envelope perform the way that they want it to perform, so that they can meet all their goals. So they're concerned about having to reduce the amount of glazing in buildings. Obviously, all the glazing has to turn probably going to be triple glazed from that in new construction like that, or some form of double glaze with an insulated vacuum glass unit hybrid, if that technology finally gets to where it needs to be. But yeah, there's definitely difficulties. And then, part of the code also talks about the embodied carbon of the materials that they're using in the construction. So they're looking to actually switch out. So concrete and steel are highly carbon intensive materials to create. So that adds to your embodied carbon. So when they're looking to build stuff, they're going to be looking to change the materials that they're using to actually build these. So mass timber is something that they're looking at. Low carbon stuff that you put in so they can meet their overall life cycle carbon cycles on this. So I mean, the energy stuff that we talked about and the envelope and the retrofitting is all one part of it. But when you come into the new design, these are the real headaches. I think the technology and the mechanical is definitely there, but how the envelope is put together and where it's sourced and how they meet those carbon limits on that, and the solar heat gain and the coefficients and all that sort of stuff that's in there. That's something which is a real struggle coming under these stretch energy codes, and it's all achievable because it's been proven that it's done, but it's just they're going to have to rethink some of these companies just going to have to rethink their standard design and come up with something new and figure it out. And hopefully we can help them.
Yeah, I'm sure we can help. This has been fantastic. I don't know if anybody else listening could, but I could geek out and go on for another hour about this, but we have to come to a close. I know we all have different commitments and we need to move on, but this has been outstanding. Thank you both for your inputs. Moral of the story is we can meet these. We can meet these criteria. We need to work together to do it on new or existing building. I think there's often an unrecognized value proposition in the interplay between the building envelope consulting professional and the mechanical engineering professional. And I think it could really offer a more optimal cost to value ratio, not only in the front end specifying of the performance of materials, but in the long end operation and maintenance of a building. So a lot more we can talk about in the future, which we will. But we are done, ladies and gentlemen. That has been another episode of the Creating Structure podcast, the energy discussion. I've been talking with Mark Schow, PE of Elevated Design, David Kent, Lead AP Senior Design Consultant with Wheaton Sprague. I'm your host, John Wheaton. Thanks for listening. We'll catch you next time. Have a great day.